Today I'm going to take a look at building the PCB for the overvoltage clamp. So today should hopefully be all the milling done, and in the following video I will try to get to the construction and testing. Now I've got a 70 by 100 millimeter PCB double-sided board loaded up already, and I've centered my fixture or the machine on the center of the board because that's how the file's been set up. So the first thing you have to do is we have to drill the alignment holes so that when we go to flip the board it will align and allow us to drill through later on to create the through hole locations. So I'm just going to go ahead and zero up the machine. So now that the Z-axis has been calibrated, it takes a little longer on this one because I've got a really slow feed rate. We can go ahead and load the file and drill. So there's the alignment drill file, and we're going to send it. Now that that is done, we'll clean up and we'll set up the bit for the V-bit. So the next step is that we need to do a Z-axis calibration of the surface, and I'm just actually going to load up the file for the top side. And to do this, we need to create a mapping. I haven't zeroed the V-bit yet, so I'll just go ahead and do that. So while that's going ahead and calibrating, so what the ZCal does for the height map is that it will go through a grid and take a measurement of what the Z height of the PCB board is at that spot, and then it'll provide sort of corrective height adjustments to the G code as it's being executed. And this is really important because the PCB board is not flat. You cannot get it to be flat, and no matter what you do, there will always be variations from one end to the other, and this will cause your trace widths to deviate quite a bit from what you're expecting, and or it might not cut at all depending on which way the board is warped. So for my board, I'm going to have a fairly large number of grid points because I want to make sure that the cut is good. Now I've had a lot of problems with the height map working correctly on the Candle software. I'm not sure if it's just me not executing it correctly, but when it does work, it works really well. Okay, so that Z calibration is now done. So to create a height map, you need to have that menu actually exposed. And you can see that when you go into the settings in the service, that you can actually select it to be visible, which I believe is right here. So just make sure you click on that to select it, and then it'll show up. So the first thing you want to do is actually do a create height map. So I've got a fairly, like I said, large grid, and you need to add your dimensions of your board into it so it knows where it should be probing. So in my case, my workable area is 90 by 50. And so this is already set from the last board that I'd used, and I had a fairly large grid. So this will take a very long time to go through. But to start it, you literally just have to start with probe. So this will take probably, you know, like an hour or so to do with that many points. But you'll see that it's going to stay within the workspace that's defined. And obviously more points is better, but it also takes a lot longer to do. So you kind of have to judge how many points will work for you reliably. And that's going to be just through experience. And I don't have enough experience yet to say that I can reduce this down to a much lower count than I already have. I'm sure as I spend many hours doing this, I'll slowly reduce the count to something that's more manageable for a grid count. So the SAD calibration or the height map has been completed, and you know, if you look at the screen, you can see that it's not a flat surface, and this is why you need to perform this before doing an actual milling operation for PCB. So because it's done, we need to save this, and to do that, you just do open, and you say yes to saving the height map and call it something. Top height map. Okay, and so we now want to apply this height map to the file that's loaded. So we can do that by leaving the edit mode, and then we're going to say use height map. So now it's applying the calibration to the G-code that's loaded, and everything should be ready to go, and we should be able to just start the file now. So this is going to run for an hour or so, and when it's done, we'll show the results. Okay, so the top layer is done, and it actually turned out pretty good. I can get this to focus in. So everything's nice and clean. There's no miscuts anywhere, so everything cut to the proper depth and then didn't cut too deep. So the next thing is going to align on the alignment pins that I put in here. You can see my board's gone through quite a few iterations of use. So there's been a lot of experimentation, a lot of failures. So because this was laid out like this, I need to flip it on the y-axis. Anyways, I'll go and set that up and go through the height map, so the z-axis calibration for the height across the board, and start the bottom of the board. So one of the things that I did that's been really helpful is I actually 3D printed up some compression strips. So I have some closed foam or closed cell foam here to allow me to compress the board down and not have it move around. So this is just made of PLA plastic. So the good thing about this is that it's low profile and means I can just peg or pin the corner or the edge of the board down. The second thing that's good about it is that if I have made a mistake in the file and have exceeded outside the limits, that when the bit hits this, it just cuts into the PLA plastic rather than hitting a hard stop like the metal bracket or clamp that you would normally use. So if you hit that, your bit's done. Hitting this, it doesn't really matter too much, it just eats through it because it's so soft. So if you do have access to a 3D printer, I'd really recommend making up something like that. So it certainly aids in securing the PCB board down. So I'm just going to go ahead and set this up for the bottom layer and get it going. Okay, so the height map calibration's been completed for the bottom side of the boards. We'll just say okay to that. So you can see the variation across, and again, this is why you can't mill a PCB reliably, is because it is not flat and it'll never be flat. So the next thing we want to do is save this. So again, you go to the open, you say yes, you're going to save this file, and rename it to bottom height map. Okay. Now, again, I've had a lot of problems with height map actually applying its values correctly to the file. So let's edit or leave edit mode and use the height map. So now it's applied it. And what I've been finding is that for some reason I have to do a second Z calibration after this is completed in order for the map to be correct. And I don't understand why, but I'm going to give it another try again with it applied as it is, and if I have to stop it and do a re-Z calibration, then I will. So let's go ahead and start this. And okay, so we'll just let that go and run until it's done. So the bottom layer is now done. I did still have trouble with the height map, and as you can see on the far left, there's a little bit of copper still in between the traces. So I'm just going to go through with an X-Acto knife and clean that up once I've drilled the holes. So now this is just finishing off with drill the holes and then cut the outline of the board, and then this PCB will be ready to be populated. So this is the finished drilled and separated PCB board. And yeah, so did not too bad a job, and I got some cleanup here because my leveling didn't quite work, so I just have to go in with the X-Acto knife and just kind of clean up a little bit. There's only a little bit of copper there, but once that's done, then I can go ahead and you know, populate the board with its parts. So next video I'll show what that looks like, and hopefully we'll have the backboard that gets attached that has the MOSFET driver and power supply, isolated power supply on it, and we'll have that together and maybe have a PLA box closure for it as well.